when it comes to auth, we shorten that word to auth because it's actually two separate words that we've combined into this like one monolith in the internet, right? There's a difference between authentication and authorization. Does anyone kind of have an idea of what the difference would be? Sure.
Authentication is like validating information, and authorization is just allowing people to see that certain things.
That's exactly correct, right? Authentication is simply, are you who you say you are? And authorization is, are you allowed to do this, right? So for example, let's just say you're signing into your banking app and you're authenticating who you are. Hey, my name's Evans Wang. I am who I say I am. Now I'm logged in. Should I be able to withdraw money from any account in that database? Yes, absolutely. Absolutely not, right? I'm not authorized to touch anyone's money except my own, right? In the same way in the TSA, right? Has anyone like flown on the on a little airplane before? Okay, great. So you go to the airport, right? You show your ID, you claim you are who you say you are authenticated, and you are handed a boarding pass. That boarding pass authorizes you to get onto one bird at that airport. Right? I say bird as in like plane, sorry. Weird terminology. Cool? Any questions on the difference between authentication and authorization? Is this GIF too distracting? Great. So, part one is just authentication. All we're going to talk about is how do we authenticate somebody on the internet, right? The idea here is that there's some sort of password, there's some sort of secret key that only you and I know, so that in case there's ever a point where I can never see you ever again, if I know and you know this secret word, then I can prove that it's you, right? In the same way that, like, if you were to try to implement this in like some sort of like secret society social group, like the Freemasons, and there's like this secret handshake where like if you experience this handshake with somebody else and then they give you a particular response, then you know that they are a member of the Freemasons. Does that make sense? So on the internet, of course, you can't see anybody. You can't like always ask for like their driver's license. No one wants to upload stuff to the scary internet because it's dangerous. So this password system was born. Right? So far, so good. Boom, boom, boom. This is right. In order to do that, does it make sense, right, when sharing these passwords across the internet to store them in plain text? Right? Like if your password was password, in my database, your username is like jabroni, and your password is password. Do I want to store that in the database? No, definitely not, right? Not as a plain text password. So I must do something to this password. I have to hash it. And what that means is just I'm going to take it, like password, I'm going to run it through some crazy mathematical algorithm so that it is completely unreadable to the point where nobody can possibly guess what it is based on this unreadable string. In the same way that you saw the encrypted string from the key value pairs in the cookie, or in the session rather, inside the cookie, right? That's the goal we're trying to achieve. Now the problem is, usually there's some sort of hashing algorithm is reversible, right? Like if I do certain things mathematically, then I can essentially always effectively reverse engineer it, and then I should be able to get back that string, right? Like in theory, this is like the worst hashing algorithm in the world, but if I had some string like password, I can in fact run a very complicated algorithm on it, and now I have essentially a different string. The problem is this is very easily reversible. It has taken several MIT grads with doctorates to come up with this algorithm that cannot be reverse engineered. And the way they did that was they would take this and always add a random piece of string and then run it through their intense algorithm, right? And the key is this random piece of string needs to be added every single time. And has to be different every single time, because if I have the password and you have the password, it should be different in the database. Otherwise, essentially, I can just sort of look at it and figure out Like, hey, you're using a common password because I've seen this exact combination of strings before. Does that make sense so far? Great. So we use something called bcrypt, right? Bcrypt is a fairly known industry standard in terms of hashing and in terms of like jumbling up your string. So here we're just in the IRB, so I can simply require what the great. And so now I have bcrypt. It's just a gem. I've installed it already, so I have access to it globally, and all I have to do is require it in my terminal session. So far, so good. So what I can do is bcrypt is exactly what you think it is. It's a gem, all right? So it comes in its own module. So I can do bcrypt. I can check the password. There's no, I forgot what it is. Nope, that's all of this. Let's check the docs. Great, I have these docs, cool. Bcrypt is a module and inherits from, oh, sorry. Embarrassing. You've seen namespacing before? How do I do it? 2 colons, right? So bcrypt is a module, and inside the module there's a class password, right? I saw this here and I gave it away. I forgot. Cool. And all I want to do, right, is look, check it out. It's just a class. So knowing a class, it probably has what method attached to it? Initialize, right? So I can create a new instance of this. So I can create, right? And for whatever reason, when I looked this up the other day, Michael was like one of the top 10 most used passwords of like 2018. I don't know. People are weird. And it should give me this crazy string, right? Would this be effective to store inside my database? Absolutely. Say again? Well, our friend is really annoying. Great. So let's talk about that for a second. There's this idea of a rainbow table, right? And what is that?
Somebody has gone and run all the common passwords through the hash algorithm so that they know what the clear texts are. And they can reverse engineer it, but that's my brute force.
There's the thing about that. So what a rainbow table is this will make more sense in 2 seconds, actually. Let me get to the next part and I'll explain it, cool? So I can create new instances of this bcrypt password, and it will give me this hashified string. So you see this here? This right here. I'm just going to copy it, and I'm going to paste it. Cool? And so what is this? What's the string, right? So what if I run Michael again? What happens? The theory is that I should not see the same one, right? So bloop, 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 bloop. And they're all different. Even though I'm putting in the exact same input, the output is different because of that salt, because of that difference in what's... It's called the salt. It's like that random string that gets added, right? So the theory is, can I do this, right? This first one, and can I compare it to this? What do you think I will get? False. I should not be able to run it every time I create one. However, let's check this out. Let's do this. Let's put, I don't know, super cool password equals to this string right here. Bloop. Cool. So far, so good. So this pass is just a string. All right. And is this password the same as, let's do this, bcrypt password. Put new instead of create. And let's check Michael. Oh, man. What is this? Does it not like the single? I find that super bizarre. Should take new. Interesting. It doesn't like this. Should be a string. These are all my notes here. I'm just gonna look through them. That's not useful. Should update these notes. All right. Oh. Yes. Let's try putting in password in here. That's what it is. Cool. This is so weird. Yeah. Apparently it wants a hash. You're absolutely correct. Who said that? So smart. So smart. I should have read the error message. I'm embarrassed. So, what's happening here? This password, right? If I check it against this password.new passing in the string, it's coming up as true. Cool. So can I do the string Michael and have it double equal the bcrypt password, passing it in the password. I can't compare it directly against like the string or anything, but if I have the hashed password and I pass it into the bcrypt, I create a new instance of it with the original hash, I should be able to double check and compare it against the old password. Does that make sense?
So you just created a new password with the same encrypted hash?
Say again?
What did you do with an encrypted password that went out? You just passed in the same thing that it was equal to, right?
I can return this value if I pass in new, right, versus create. So new and create are not doing, this is the first part that's really confusing about this. New and create are not doing the same thing you think it's doing, right? So what you think normally what new does is it creates like an instance, right? So you can have like user.new. I don't have user here. I'm not in the Rails console. But you would do user.new, right? And you get like ID nil, name nil, password nil, all these like nil values. Here, when you instantiate a new instance, you'll have to pass in this hashified string, which you'll store into the database, and you could check it against what the user sort of puts in. Does that make sense? It wants it as a hash. This is very interesting. I'll show you this. Pass in the password. What do you think? Take a look at this. Take a look at this. Right? It's part two of the really confusing thing. So part one, new, right? Will return this like hashified string. which is kind of a little bit interesting, as opposed to like what you think it'll create. So new and create do two different things. The second thing is, if I were to check the string against this, but I would check this object against the string, one returns false, one returns true. Here's what's happening. Michael is what class? String class, right? This double equals, and here's what you forget because there's so much syntactical sugar in Ruby, is there is a method called double equals passing in the argument of this. The double equals is a method call. Is that familiar from like literally day 2 of mod 1, right? Everything responds to a call to a method. Therefore, this double equals is defined on the string class, right? Does that make sense so far? If, however, I were to do this, I'm essentially calling a method called double equals, passing in the argument of Michael as a string. So far, so good. Who remembers monkey patching? Does anyone know what that is? Who's not familiar with monkey patching? All right, monkey patching just means that I can literally overwrite anything I want by going straight into that class. Cool? Like, so for example, there's a class array. Cool? What's a method on array? I don't know, length, right? So like I can put def length. I can go into this method and I can just simply say return 7 for no reason. So I end the method and I end the class, right? Now I have an array, 1, 2, 3. And what would I expect to see, length, very good, when I call length? 7. I just went in that class and I overwrote the length method, right? It's called monkey patching. Therefore, what's happening here is this double equals is being called on what class? A string class or the bcrypt password class? The bcrypt password class. Therefore, if we look inside the actual documentation under model bcrypt, takes class password, it creates a class password that inherits from class string. And what does it do? Boop, boop, boop. It overwrites the double equal sign. So the double equal sign is not actually the exact same comparator that you're used to. It just looks the same. Does that make sense? Is anyone confused as the two kind of weird things about bcrypt? So the idea here is that I should be able to, this password, right, is what we stored in the database, right? After we ran through that bcrypt.create, it spit us back this weird string. I saved this string into the database. I should be able to call bcrypt.new with this crazy string and compare it to a user input, like a login form, right? A login, user's gonna put in what? The username and password. So on my params, I'm gonna have params username, and I'm gonna have params password. I should be able to check this bcrypt password.new with what's in the database, the crazy hashified string, compare it to the params of password that the user input. And if true, then that would mean that that person has, in fact, the correct password. So if, for whatever reason, somebody was trying to hack source into your account and just put, I don't know, password, it should return false. Like, this is not actually the correct password. Yeah?
So the doc's like a monkey patch it because the comparator, the numerator wasn't like actually returning the right value. Is that why
100%. The reason it was monkey patch to be different is because this is the original return value, right? And that is the exact equality. Meaning, is this string Michael equal to this string? And it'll never be true. So they had to override it, and it only works one way, and that is it must be, the double equals must be called on the bcrypt object. Does that make sense? You can't have it the other way, otherwise you're calling the double equals on the string. In which case it will literally do exactly what you think, and that is compare string for string. And that will not work. This usually gets a lot of people. The idea here is this. Let's just say, is anyone here like a vegetarian or like anti? Okay. So let's just say you have like a vegetable grinder, right? Thank you. You have a vegetable grinder. I'm not going to compare it to anything else. And you have broccoli. Cool? Broccoli has no feelings. You put broccoli in this vegetable grinder. And you're grinding up this broccoli. And then on the bottom, you get this like green mush. Can you compare this broccoli to this green mush? Like, it doesn't sort of look the same, right? You can't identify in this green mush immediately, all of a sudden, like, oh, like if you look at that mush, you can be like, oh, that's broccoli. Could you do that? Probably not, right? If you can, I'd be very impressed, right? But let's just say you put in like some different ingredients. You put in broccoli, you put in celery, and you put in like a radish, something. And you put it in this vegetable grinder, and now there's like this really jarbled mush. Could you look at that mush, right? Think of it as like this stringified hash, and immediately go, oh, that's these three ingredients. I know that for sure in my heart. Can I immediately look at this and be like, oh, that's Michael? How could you not see that? There's no way. Can you put it back in the vegetable grinder and get back the fruits? No, right? There's no way you can take this and then reverse engineer the algorithm to get back Michael. It doesn't work that way. It's a one-way transformation. Does that analogy make sense? However, through the magic of science and DNA, is there a way to test parts of it and test to see, hey, is this part of it broccoli or a radish or a celery? Thank you for not seeing color. You guys are great. You see what I'm saying? So the idea is that it's a one-way transformation, but there is a way to still check what the origin is without being able to transform it back. Cool? bcrypt gets a lot of people. Yes, no? All right, cool. Any question?
So, it is checking and seeing that it's Michael.
Yes. This way.
How is it doing that?
If any of us knew,
Okay.
this wouldn't be secure,
Okay.
right?
It just hashes Michael and sees if the hashes are the same, right?
Yeah,
Michael plus the salt and then compares them.
correct.
It can't reverse it. It just goes.
Yeah. So
Then when the results the same.
So let's take a look at these docs to check out what's happening under the hood. All right, this double equal, passing in this secret, right? The plain text password. What it will do is it will call super. What's super? Besides like awesome and a hero. Super will call the exact same method, right, in the parent class. So it's calling super on this bcrypt engine. The method hash secret. This method right here is not publicly available. This is like the bread and butter of bcrypt. Under the bcrypt engine docs. Oh, I'm so sorry. All right.
That's a gem.
bcrypt's a gem.
And it has a module engine that is private.
So when I call this comparator, I pass in Michael. right? It will check the bcrypt engine. It will run the hash secret with the password and the salt. What is this at indicating to me? It's an instance variable, right? And as we learn, instance variables are attributes of the object. So I can, in fact, see looks like a string, but in fact is a bcrypt password object. Therefore, what attribute did I just say should be on this? Cool. So it will take the salt, which is like the random string, along with the plain text, and then it will run its super secret code just to see if it is in fact equal to the plain text password. Yeah.
So, like the first 7 characters are the same every single time. Is there like a way to sort of like get some parts of it out?
Yeah.
Looking at it?
Yeah. There are ways to get parts of it out, but the salt will be random every time, so it's not super useful. It will only be useful as you pluck through individually every single one, and that becomes very time consuming. So, yeah.
Salt is just like a random string of characters, right? So it has nothing to do with the actual password, it's just to make it more secure.
Yeah.
So what can you just do with salt and then decode using just reverse engineer using the second half?
So if you notice, the salt looks exactly the same as these first like 20 characters. So what you're saying is, can I just take this and reverse engineer it? It actually doesn't work that way, because this whole thing was utilized to make it in the first place. I'm not sure if that made too much sense.
I guess it's an algorithm.
Yeah. So back to the point of rainbow table. Yeah. That's okay. What's up?
Oh, there's a dot at the end of this salt, and I was wondering if it delineated the salt versus the regular.
No. It could be anything. I think it just happened to be a period right there. Cool. All right, so back to the rainbow tables, right? The idea is that what they'll try to do is, let's just say you had a list of the top 100,000 passwords used globally. That's not that hard to find, right? What they'll do is they'll literally run bcrypt password new, passing in every single thing in the database, comparing it against every single common password that exists until it runs true. This, you can imagine, takes a lot of computational power. Bcrypt is not a very efficient algorithm, specifically designed to be not very efficient. If you take the runtime of how long it takes to run bcrypt.new password and compare it to a string, it actually takes like a second or two. The longer you do it, the slower it becomes. And so to compare it against like every single password becomes very, very, very time consuming and computationally consuming. And so it's hard. So it's not physically impossible to crack your password. All it takes is running bcrypt password new, passing in what I stole from the database, right? The hashified string, and comparing it against every possible combination of letters and numbers to exist on the face of the earth. 100% possible. It would take me days, weeks, months to break a password. One password. Great. Sorry, I just started the recording again, and for whatever reason, I have this terrible habit of saying great. So just, if you watch these recordings, like lower the volume, because sometimes they just come off really strong for no reason. Sweet. All right. So the idea here is that I would have some sort of user password, right? Oops. I would have some sort of user password, right? And all they do is they sign in, right? Is anyone confused on this form? Hopefully not. It's like week 3 of Rails, right? It's just a form 4. I have a username and a password. And so when I do form 4, What does it do with this instance and these text fields and these symbols? What does it do? It calls it, right? It literally will do @user.username, @user.password. And if it finds that all these values are nil, right? If @user.id is nil, what does that mean about the @user? It does not exist in the database. Therefore, the f.submit will probably say something like create user. So far, so good? And so that's why, again, as a quick review, why we would need @user equals user.new in the new. Yeah? Great. So let's take a look at our schema. What do I expect to see as my attributes? Username and password, right? Let's take a look at that. This is my schema. I have a username, and I have something called password digest. Ignore this for now, it's not important. I have something called password digest. Why would I name my attribute password digest and not password? Well, I'm going to run into an error, right? But why would I want to name my attribute password digest as opposed to just password? That is the end result, and I like where your head's at, right? So you can kind of think through. So here's what's actually happening. Remember, @user.password is what it will call. Therefore, if I do not have a password attribute, what should I expect to see when I load this form up? This works because straight up in my user, I wrote this. Naturally, you would see great, there it is. Undefined method password. Did you mean password digest? Right? This is the error you all expected to see because @user is calling .username. So what I can do is I can hack it for a little bit, and I can create this method password, and it just returns @password. What is @password right now? Nothing. Right? There's no real value. It's just nil. Hell, I could have put got 'em. Right? It doesn't matter what I put in here. This sort of is just what you can imagine is like a placeholder because @password doesn't actually exist. It's just returning nil. Right? Because this attribute does not exist on my user. So far, so good? Okay, cool. So the idea here is when I submit now, because remember, it called @password and it came up as nil. So when I hit create user, what will it try to do? What will this form for do? Right before that, what does form for do when I submit? It hits the create action in my user's controller, right? So let's do this. Ignore the rest of this code. I just had to kind of write it in since we're running out of time. Great. Look at these powerful. New Guy Fieri, right? You guys didn't like Flavor Town. Let's not go to Flavor Town. You guys have killed it for me. Alan Turing. Password is okay. Cool? Great. When I hit create user, I should hit that create action. So here I am in the bybug. If I were to check my params, I get username and password okay. When I try to create this user using the user params, right? What are user params? Username and password. What will it try to do? If you think back to Mod 1, active record, adder readers, and adder writers. What will it try to do? It will try to do something like, oh, hey, password equals. It will try to do the attr writer for this. So naturally, what can I expect as the error when I run this? Undefined method password equals, right? Unknown attribute password, because it cannot assign password equals. So far, so good? Great. So let me just hack it. Cool. Bloop. All right, I'm going to take a plain text password, PTPW, and I'm going to write this password equals method. And I'm going to take in a plain text password, because that's what it does, right? This is the attr writer. Password equals to whatever params you want to put in, like new password, right? But here I just put PTPW because this is going to be plain text. I have access to, what is self here? The user, right? Does the user have an attribute called password digest? Yes, based on the schema that I showed you earlier. So self.passwordDigest is going to refer to that specific user's password digest attribute. As we currently know it is going to be empty. I can use this because Active Record builds the attr reader and writer for me for all the attributes I put inside my migration. And now I'm going to create the hashified bcrypt password and store it in there. So if I actually run this and save it in my database under password digest, I should see some crazy hash. This is when you get really good at Rails. You can manipulate it because you know what it's doing. I just put password in here because I want it to look just like password, except I'm going to intercept it, take the plain text password, and then now assign it to a new attribute, a password that has gone through bcrypt, gone through that hashing process, and is now digested through the bcrypt vegetable grinder, returning me this crazy string that I can now assign as an attribute and safely store it inside my database. Yeah.
When you're creating the model in the beginning, you're explicitly calling that column password digest?
That is 100% correct.
Can you call it whatever you want as long as you're consistent, or is that like a set thing?
I called it password digest, and I see where you're going with that. Yes and no. Yes, you can call it whatever you want as long as you're consistent, and I will tell you no why at the end of the lecture. Cool? The idea is here, like if I named this like password, like bcryptified password, if that's what I wanted to name it, then simply inside my controller, boop, 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 boop. Where's the user controller? Sorry, in the user model. Then I would just do self.bcryptified password as an attribute here, as long as it's saving it correctly inside the database. So far, so good. That make sense, everybody? Great. Boop, boop, boop. What are my params now? Cool. So all I did is I refreshed it and I submitted the form again. But this time, I have the password equals there. Look what happened. Begin transaction, insert into, password digest is a hashified string. And that makes sense because I literally wrote that attribute in there as a brand new bcryptified password. Should be like thumbs up. Great. Now, from here, I have access to it. At some point, right, this is where I just need you to make a logical leap with me. At some point, you will log in, right? There will be some sort of login form, right? And the user, like I said earlier, will submit a username and a password. What method, what controller action do you think that'll hit? It's going to hit a custom controller action, right? Because login is not a RESTful route. Login is not part of CRUD, right? Get out of CRUD. Get out of it. All right? If it's not if it's not one of the 7 RESTful routes, the correct answer is custom route. Cool? Just because that's exactly what it's doing, something outside of CRUD, right? And so the idea here is that when I log in, I have a username, right? Params username, and I'm going to have params the password. What I want to do is with params password, I want to authenticate. Like I said in the beginning of this lecture, we're here to authenticate. So this is what we're going to do. Inside that custom method, it doesn't matter where it is right now, it's not important. Inside this custom method, I will probably doing something like user.userFindBy username, right? And does that person exist in the database? Does I don't know, Guy Fieri exist in the database? Yes, great. So now at user is user 7, right? Who's Guy Fieri with a password digest of like some crazy string. So remember, I have params password. All I want to do is check to see if, and this is not really going to work. If, right? Remember I said password.new takes in the bcrypt password hash from the database. And I'm just going to double check it. Does that equal to Michael? Exactly what I showed you in the IRB. And if this is true, then return to me the user. Else false, right? So like, if this is true, then at user, else false. Oh my God, look at this indentation. Trash. Cool? And the reason I wanted to return false specifically is because I want to make sure I can explicitly determine whether or not this failed. And then, thinking through the next steps, if authenticated, then I can create session at a key of user equals to at user.id. Right, now this session exists because they've been authenticated, and now I am going to track this user throughout my entire application because they are in the session now. So far, so good? Are there any questions on bcrypt, the hashing, how it works one way and not the other, rainbow tables? Yes?
In the labs, I don't exactly remember, but I think they had us reading the salt part separately and adding them together and separating them out again. Is that not, in the end, we just need to do the bcrypt?
You need to do 2 things, right? This project was kind of set up for you. In your gem file, you will find bcrypt commented out because auth is not required in all applications, right? It'd be crazy to sort of install this gem for no reason. Just uncomment this, bundle install. In your user model, you add this one line, has secure password. It will build all of this and add a validation that says that password must exist when you create a user. Therefore, to answer your question, if I want to use this one sexy line of code, it has to be named password digest. But if I do not want to use this one-liner and manually build this out, I can name it whatever I want. Does that answer your question? Perfect. Cool. Do you like being upset? Great. This whole lecture is to tell you, use this one line of code. But now you understand bcrypt. Again, like I told you, this first part is just me talking at you for an hour. Yeah.
So the params before, like earlier on, it had a param for password and it showed the password equals okay. Does that go away when it goes through bcrypt?
Yes. Right. That's just the params that get sent through, because it has to come through as a plain text. That being said, if I were to